Okay, now I'm going to want to use this analysis for parameter estimation. So the way that I did this was to set up some data sets that we'll use for parameter estimation. So I did that by putting in these point probes. There's a point probe here at x equals 0.15, y equals 0.1, it's shown right there, and another one a bit above that. So they're at the same distance downstream, but one is offset from the other. And so I ran this and ran the forward model, and then I used these point probes to generate data sets that I'll have be my simulated experimental data. Okay, so I did that, I put that in a file, and then I'm going to use that I'm going to import that file as for my analysis. So one way that I've done that is I brought that data in by, I opened up a table down here, and then I tied in the table with, basically imported the data from the file that I created. This was a CSV file that was created in Excel. I brought that in, and here are the 4 columns. This is time, X location, Y location, and the value. Okay, so this is one way that we can get the data into the software, and we could plot this and take a look at the data. Okay, so what I want to do now is to show you how the optimization is set up. I put an optimization node in, and we use least squares objective. And if we open this up, there are 4 columns in the data file. Time, that's the X location, the Y location, and the concentration. And if you check out the data file, you'll see that there are 2 points, and this is it. You can tell this because the X and Y location changes, and the time repeats itself. So we've got data points that are measured at 2 locations, but at the same points in time. So this is the input data, and then in order to run this model, I need to really have a flow field done first. So I set up a stationary study, and it has just the Darcy's law. And so I run that, and then I run the transport here, and I initially ran it without the optimization turned on, just as time dependent. And let's see if we take a look at this. So I had it just the transport without Darcy's law, and initially without optimization, and I ran this for 120,000 seconds, so that's about a day and a half. And then in order for this to work, I need to be able to have the transport simulation use the heads from the Darcy law simulation, which was done in steady state. So for the values of variables not solved for, I'm using the stationary solution. That'll allow me to access the hydraulic heads. Okay, so I set up the forward model that way, and then I got it running, and then I did a parameter sweep to see how the parameters were varying, and then I set up the optimization. So here's the optimization node. I'm just using the default optimization method and this least squares objective function that I just showed you. And as a start, I'm just using the porosity as the parameter that I'm trying to estimate. I start out, the actual value is 0.2, so I'm just trying it at initial value of 0.3, and I bound it here with reasonable values of the parameter. Scale is just 1 in this case because this is the value of porosity is quite close to 1. And so I run that, and this will allow me to evaluate how well the parameter estimation is able to do. And one of the things that's helpful with this is to be able to plot the results as you go and watch these results. So I do that. So I do that here. I have this point graph, and there are several ways you can do this, but I'm with these point graphs where I'm referring to the data set at the domain point probe. Those are the data generated by the model that's set up from this point probe that I showed you above. And so there are 2 of those, and those are the simulated values. And then this table graph here, this is down here, let's see. This is this table graph that I showed you setting that up. So I imported the data into a table, and then to plot those data, I set up a table graph here, and this allows me to select what columns I want to use for the x-axis. So I want to have column 1 be the x-axis, and column 4 is the y-axis, and I'm not using these 2 intermediate columns. And so here's what you get. The lines are the data from the model, and the points are from this table plot that was from the file that I imported. Okay, so this is the setup, and this allows us to evaluate the feasibility of estimating porosity from these data. And so we can run that and evaluate how well this optimization routine does for estimating porosity from these data. Then what I would recommend doing is evaluate this, and then go and try out some of the other parameters. And don't bother with x and y gap, they're not being used, but the diffusion constant, you could try that. You could also try these 2. And what I would recommend doing is try them one at a time, and use the values that are, use these default values. These values here, these are the correct values. Okay, so these are the values that I used to create the data set. So start off with these, and use these as, if you're not going to fit the parameter, just assume that you know these. And so go through this and try setting this up, and try fitting individual parameters first, and see if you can get the routine to work properly with individual parameters, and then you can start adding multiple parameters. When you add multiple parameters, it gets more difficult, it requires more iterations to converge, so I would try starting with the individual parameters and then moving on to multiple ones.